Good morning, good afternoon, and good evening, depending on where you are across the world at the time of listening to this presentation. I'm Saurav Sahu, a data steward working at Oceanographic Canada ONC, and today I'll be talking about the data lifecycle management to support a new automated data pipeline. Oceanographic Canada ONC is an initiative of the University of Victoria and operates world-leading ocean observatories and data repository services. The map shows some of ONC's Canadian infrastructure and partners, including those of the core Neptune and Venus cable observatories, along with the community observatories, including those in the Canadian Arctic. The Citizen Science Program with the Pacific Salmon Foundation utilizes a fleet of fishing vessels piloted by retirees or interested persons acting as citizen scientists for wide-scale monitoring of the Salish Sea. This has resulted in over 10,000 water profiles since 2015. ONC's role in this program is to be responsible for the instrument maintenance, testing, data management, data products, and quality assurance QA/QC. The Citizen Science Program with PSF is a part of the larger program at ONC called the Community Fishers Program. The Community Fishers Program includes similar citizen science programs with other partners, including those in the Canadian Arctic, such as Iqaluit, through the Department of Fisheries and Oceans Canada Ocean Protections Plan. The data lifecycle management incorporates 8 components and are shown here. The planning phase includes data agreements and data management plans. The collection phase, I'll focus on the new data pipeline and mobile application. The assure phase is a QA/QC done by our data specialists. The describe phase is metadata management done by data stewards such as myself. The preserve phase is when data is archived, and finally the discover, integrate, and analyze phases I'll talk about in terms of our Oceans 2.0 data search, data products, and API web services. During this presentation, I'll mostly focus on the collection phase, the planning phase, and the discover phase of the data lifecycle management. In the planning phase, a data agreement is in place, so all members understand the data attributions, usage restrictions, contact persons, etc. ONC by default has free and open data access, but this can be modified in the data agreement if required by our data partners. As with most partners, the data agreement states that ONC is usually responsible for the instrument maintenance, testing, data management, data products, and quality assurance QA/QC. The next stage is data collection. Collection starts with our citizen scientists. They receive hands-on, in-person, and on-water training with the whole instrument suite as shown here. This training includes operating the set of instruments to be used in data collection. They also get training on using the mobile application for the data transfer. Besides, they are also provided with a manual for oceanographic data collection best practices. This training helps in maximizing the initial data quality during data collection. ONC developed a novel mobile application called the Community Fishers app for the data acquisition interface and the data transfer to Oceans 2.0. Data is transferred directly from the instrument to the app while in the field wirelessly using Bluetooth. Once the app has a Wi-Fi connection, it transfers data directly to Oceans 2.0 database and web API. This is a screenshot of the app shown here. Once the data reaches ONC, it needs to go through a data pipeline. This was designed to make the process automated, scalable, flexible, and also to provide real-time data visualization. This data processing pipeline processes incoming data as shown in the figure. The data acquisition step is handled by the app in step 1. The servers at the data center process the raw data from the app with the same system that handles live data acquisition from cabled or network instruments in step 2. This near real-time automated processing parses, calibrates, and applies QA/QC tests to the data and then archives it. Once archived, this data is available online for searching, viewing, and distribution to the numerous online tools within Oceans 2.0. However, specifically for cost profile data, additional post-processing is required as shown in step 3. The next part, metadata management. Instrument documentation is collected, organized, and stored in Alfresco by data stewards. These documents include calibration sheets, reports from the field, deployment and recovery pictures from expeditions, or pictures from instrument inspections and qualifications. We create and maintain instrument-specific wiki pages and data product wiki pages which are made publicly available to external users. We document instrument history through device actions. ONC uses control vocabularies which follow FAIR principles. Currently, we support climate and forecast CF variable names, IOOS categories, CDataNet device categories, and CVOX device catalog, which are both publicly available through the NERC vocabulary server. Our metadata records are being revised to adhere to the ISO 19115 standard for all data. Furthermore, ONC adheres to the new Core Trust Seal data repository certification requirement for data discovery and identification, such that users can discover and refer to the data in a persistent way through proper citation or digital object identifiers. For data discovery, we have our user interface tool, the data search, map portal, and the web services API. A data source selected from a geographically based search tree, shown on the left in data search tool, contains regions, locations, sites, and specific cost stations with an associated geospatial area. Each cast station has a list of individual casts, and the users can filter this data by depth, time, or any measured property as shown on the right here. Users can also look at cast data collected for the Community Fisheries program from the Geospatial map portal, which shows cast stations, near real-time profile plots from processed data, as well as historical data from one particular station. Users can get a direct turnkey link to data search to download multiple cast profiles if they choose to do so. There also exists a light version of this map portal which can be accessed from low bandwidth locations such as those in the Arctic. Users can also get data from ONC's API web services. The Oceans 2.0 public documentation includes a comprehensive collection of code examples, snippets, and use case scenarios in multiple programming languages such as Python, MATLAB, and R. All the Community Fisheries program data is available through the Oceans 2.0 API as well as the data search tool. To stay organized amidst these instruments and data, we use a task-driven workflow which facilitates task management for all these instruments. The workflows ensure that the work is streamlined, traceable, and repeatable. Three main phase types are shown here: installation, maintenance, and commissioning, along with 8 phases. The workflows ensure that all events in an instrument lifecycle are recorded. These workflows are customizable, versioned, allowing for a task management tool unique to any sort of operation. These tasks on the workflows serve to make the data increasingly interoperable and fair, enabling many co-trust fields and fair best practice principles. The slide shows some of the future work as part of the Phase 2 of Community Fisheries Pipeline. One of the important ones I'd like to point out is about improving the data acquisition from the community feedback in the cold Canadian Arctic at Iqaluit. And with that, I'll leave it open for questions and comments. Thank you.